I'm James Coomer. I'm Senior Vice President of Products, and I work for DDN. Here we're at Supercomputing 2025. We're at the DDN booth, where we're talking to customers who are consuming massive scale AI about how we can help them be more productive. So how are GPUs being constrained in average environments today? And really the big challenge is data. And actually, we sometimes call artificial intelligence data intelligence at DDN, because it's really about how we turn data as a source code into applications you can run which are intelligent and provide intelligence to the customers. And when we're building those models, and when we're running those models, and even when we're preparing the data to build those models, these are all GPU operations that are constrained by data. Data movements into the GPU, data movements out of the GPU. And then it gets really subtle, right? So let's take training, for example. We run a large training model. Often these are customers which are household names. These models are running in large supercomputers, AI supercomputers, maybe across thousands of GPUs, and to train a single model might take many weeks or many months. During that time, we're constantly feeding data into those GPUs, and also we're saving the state of those models. So we know the progression, we can checkpoint these models and then basically restart again if there's any problems. And all that is data movement, and often the GPUs are waiting for that data to be moved in or moved out. When that happens, you're wasting resources. You're wasting the power, you're wasting the capital expense, you're wasting the data scientist's time, and so there can be huge wastage of overall productivity just because you're waiting for data at massive scale. So the one thing we do for training is really optimize that data movement. A, by being brute force fast. We really are extremely fast as a fundamental nature of our storage systems. But then, more interesting than that, we plug in to the frameworks, we plug into the containers, we plug into the systems, we plug into NVIDIA at various levels in order to optimize these data movements very specifically for these workflows. So that's training, and that's a big part, right? So far, the vast majority of money that's been spent on data centers, GPUs, networks, people, is into train these models that we're seeing today change our lives. And DDN's been part of making that optimal and increasing the utilization of these GPUs. Now we move into a phase where inference starts taking over. The amount of spend on inference systems is going to outpace that of training systems this coming year. And they're both growing, but inference is getting bigger. And when we move to inference, the problem is the same. In fact, it's even harder. When we're running in inference mode, running these models, not for training, but for production, then there's three challenges which DDN can help with. One is loading those models into GPU memory. Second is RAG, retrieval augmented generation. That's when the models seek out additional knowledge to supplement their response to you to give a better response. And we'll see this, we've seen this in ChatGPT, we've seen this in Grok, we've seen it in all these large language models today. And then finally, the big wave that's just coming is called KV cache management. Now that's a technical term, of course, but KV cache is essentially a construct within every inference workflow that really makes that workflow happen. It's about taking your question that you've asked and making sense of it. That's really embodied in a thing called KV cache. And this becomes a very important construct, a very important piece of data. And what we do is we handle that KV cache, we increase essentially the memory of a global GPU system, and we move this fast to share it across the GPUs. And that can make up to a 60% difference in the productivity of very large-scale GPU data centers. So GPUs, as we know, NVIDIA have been very good actually in providing us new GPUs, almost year upon year, starting from 6-7 years ago, A100s, H100s, and then now we're looking forward towards these Vera Rubin chips. And every time the memory bandwidth gets big and the data demands get bigger. And so the bottlenecks are when the GPUs are trying to run something, but they're waiting for data in one way or the other, they're reading or writing. And if they're doing that, then they're wasting resources, they're wasting productivity at massive scale. Yeah, when we talk about data center efficiency, the new kind of phrase on everyone's lips when they're building data centers is tokens per watt. And that means essentially how many answers you're getting out of this machine, be it small or large, for a given energy input. And we've seen on the news gigawatt factories, gigawatt systems being built just to power these GPU systems. So absolutely critical. They are hungry for power, and the real question is how many answers do we get out per watt? And what DDN does, what we are, is a machine that magically increases the answers per watt. By driving the data and expanding the memory, that means we need to do less compute, because we can remember more. By remembering more, we have to do less compute, and therefore we deliver more answers for a given watt input. Yeah, DDN Core is about bringing together two really amazing technologies that DDN have been developing for many, many years, whilst this world of AI has been expanding dramatically. DDN Exascaler is well known for driving the model training process and driving massive throughputs for large-scale systems at very famous institutions such as XAI, for example. Whereas Infinia is something else we've built which really delivers the smarts required to handle the complexity of this extremely complex data sets, models, data, management, people, shared infrastructure. So bringing these two together in DDN Core means that customers have a much more seamless experience and get all the benefits of all our products in one solution. Well, now's the time, right? We've seen a wave of very large supercomputers, superpods from NVIDIA, starting a few years ago. And then we've seen a new wave of NCPs, which is cloud partners providing easy services. And now there's another wave coming along, which is many more enterprises getting into AI. Now they can consume it on the cloud, or they can consume it on-prem. And whichever direction they go in, we've built these fast-track solutions to get them into production faster at lower cost, without needing all the intelligence inside the company to build solutions from scratch. So one of these things is a partnership we have with Google Cloud. If you use Google Cloud, you'll find DDN technology right at the heart of their parallel file systems to accelerate your GPU experience. So really, if the fastest way to get up and running is go to Google, consume DDN's Exascaler or Google Cloud Managed Lustre, and you get your AI really, really fast. If you're on-prem, then come to DDN, use the AI Hyperpod solution. We'll provide a full solution with NVIDIA, Supermicro, software, and DDN, all packaged, all sized and optimized and ready to go. So how are we handling this convergence of HPC and AI? It's a massive topic. I could literally spend an hour talking about this, but we can break HPC and AI down into, let's say, 4 big use cases. In HPC, big, fast scratch. Monstrous HPC simulations, punishing the compute, punishing the data in order to provide the output, quantum mechanics, fluid flow, oceanographic simulation, whatever it might be. Then, still in the HPC world, we have to manage that data. We have to manage it responsibly, share it with others. And then AI comes along, and then as we've been talking about, we've got this training and inference problem, different data problems. So these 4 combine, and this year they're really combining very, very fast, such that new platforms out there really have to deal with them all. And as far as the storage is concerned, the data platform is concerned, that means handling myriad I/O data patterns, the heavy HPC, the weird and wonderful inference workloads, the training workloads, the research data management, the metadata intensive stuff, all of that, plus the new use cases that come along around controlling this data, sharing it securely. And really what we do is bring that all together into one platform which does all of that stuff. And I honestly don't think any other storage player can say that same story. Something that can support all these major use cases and all these themes around security and sharing as well. So sovereign AI, we've been going around the world, as has NVIDIA actually, talking to customers about how they can ensure that the benefits of AI work for that particular nation, right? And there's multiple elements to this. One element is you really want to be able to share with your nation models that are being generated from data that's relevant to your nation, your language, your culture, and not be really polluted by external influences necessarily. And so that's part of it. And then the other part of it is how do we take what a nation is already good at, whether that's making cars, whether that's building energy systems, whatever it is, and really put that on steroids, like just turbocharge that with AI. Both those things come into play. And then what's in common in terms of solutions that DDN provide is security, the ability to deploy fast at large scale within different nations. That means global support, global management, global integration with our NVIDIA partners. And then finally, secure data sharing. So infrastructure sharing, these systems are massive. Even within a nation, the data needs to be protected and shared very carefully within those communities within that nation. And we tie all that into all, of course, of the scale and performance we expect from DDN. Partnership is essential because our customers are really coming at this problem from many, many different angles. They might be consuming cloud, they might be consuming on-prem, they might be doing a hybridization of both those things, and also they want to do it at maximum efficiency. And really, this is back to the kind of tokens per watt play. How do we do all of these things according to those customers' preferences, cloud, on-prem, etc., but all super efficiently? Now, nobody does anything efficiently by doing things on their own. We got to connect. We got to plug in. The cogs have got to connect very closely and seamlessly without any energy wastage. And so this is what these partnerships are all about. It's connecting our stacks. It's connecting our software so that as a whole, we deliver more from the component pieces. AI factories are really quite complex systems that allow you to simulate the real world and bring together a lot of technologies around data preparation, data management, data training and simulation and production into one system. So it includes multiple components. So one component is the training part. One component is possibly edge deployment. So you might have to let that model that's been trained out into the wild and help, where it's going to go and help people live their lives better, whatever it is. And then the third one is like NVIDIA's Omniverse. It's a place where you have a very large sort of play area. You can build virtual models and test them out in a virtual space, running these AI models and perfecting these AI models. When you bring all these three together, you actually get a really tough problem in terms of data, particularly with this Omniverse, this AI factory with running HPC simulations in combination with the AI. Is a tough mix, and that's where DDN really excels. It's trying to serve that really tough mix of applications in order to serve AI factories with high efficiency. So if we could give one piece of advice to organizations trying to build AI at large scale, I think our advice, and you might predict this, would be to think about the data first. Often data is an afterthought, and people think about GPUs, etc. They're very important, but fundamentally without the data, you have nothing. You've got to make sure you de-silo the data, regardless of its location, its ownership, and its data type. And what we do with our technologies is give you a secure software platform that allows you to access that data regardless of the previous silos. We really break down those silos regardless of geographic location or data type.